11. Don't let me forget to do which ones are, where's my sheet at? So the test worksheet is, number 1 is on there. But I say something different, so we got to work that out first. All right, x squared plus x minus 56. All right, so this one says you are trying to figure out what numbers cannot work in the bottom or what numbers are not in the domain. The domain is all the numbers that x can be. So you want to figure out the numbers that x can't be. So the way you do that is you set the denominator equal to 0. And that will tell us what numbers x can't be. There's a couple different ways to solve this. Most of y'all probably do the difference of squares way and say, okay, x times x is x squared. 7 times 7 is 49, a plus and a minus. And then set them both equal to 0. How you want to get a paper? So you get x equals -7 and +7 when you subtract 7 and add 7 on the one on the right. So these are the numbers that x can't be, okay? So that is your answer for the problem on the test worksheet. Oh, wait, I'll say this real quick. The other way to solve this, which I think is slightly easier, but if you just have x squared, you can solve for x squared and then do the square root of both sides. So you get x plus or minus 7. Doesn't matter which way you solve it, though. That's just a different option there. To do the test work page, draw the number line and write your domain and interval notation. So I don't make it a test question, but I just wanted to see if y'all do this. This is kind of hard, so doesn't really hurt you, but I do this. So the number line, what I mean by draw the number line is my answers are -7 and 7. What the actual domain is any number that x can be. So it could be any number less than -7. It could be anything between -7 and 7. You do the or symbol for in between each of these. Or it could be anything greater than 7. Okay. So I didn't make that worth the test point to make you do that. I just let you put the wrong answers, like it can't be -7 and 7. But that is a big idea that we do in college algebra, so I want to make sure y'all kind of have the idea of how to do that. The writing it in interval notation is the harder part because technically the domain is all the numbers that x can be. So that's the true answer for the domain. The problem on the test just asks what numbers x can't be. So x can be anything less than -7, between -7 and 7, or greater than 7. It just can't be -7 and 7. What's the next one? The next one on there. Oh, 2's on there too. All right. Enter the graph of the function in the figure below. Oh, the entire graph of the function, not enter. So this one is asking for the domain and the range. So remember, the domain is your x values. What x can be, like we just did on the last problem. So it's how far left to right. So the furthest point left of this one is -4. You are going to use a bracket because it's a closed parentheses. And then on the furthest point right is 5, and you use a parentheses because it's an open circle. And then for my y value, I'm sorry, my range is my y values. So how far down to up? I know that's a little funny to say, but you want to start at the bottom and then work up because you always start at the smaller number. So the bottom of this graph is at -4. That is a parentheses because it is an open circle. And the top of this graph is at 3. That is a bracket because it is a closed circle. So the domain is how far your x's are, or what your x's on the graph, and your range is your y's. In your own words, write how you find the following on the graph is what the test work page says. So I kind of wrote it right there, but basically you want the domain is how far left to right, or your x values, and your range is how far down to up. So you can write that any way you want in your own words, whatever helps you solve that when you're looking at the graph. All right, next one we do on there is number 4, so number 3 on the test. Below is a graph of y equals the absolute value of x. Translate it to make it the graph of y equals x minus 3 minus 2. Okay, so the minus 2 on the outside, I guess the minus 3 on the outside always does the opposite of what you say. So it moves it to the 3 to the right. And then the minus 2 on the outside goes up and down, so it moves it down 2. So this one moves it to the right 3, and this one moves it down 2. So we just go to the right 3 and down 2. Hopefully I kept the transformations easy on the test, or easy-ish. All right, number 4 is on the test work page. Write your equation and write what each transformation does. Oh man, that needs to be number 3. Can we change that to number 3? Because number 3 would work a lot better on that one than this one. So remind me to change that on the test. Sorry. Let's change this. So our equation was the absolute value of x minus 3 plus 2. So I just kind of want you to write what I had right there. I want you to write that goes to the right 3. And that one goes, oh, it was minus 2, wasn't it? That one goes to the down 2. So this would work a lot better on number 3 than it would number 4. All right, back to number 4. Number 4, when you have a negative on the outside, it reflects it across anything on the outside goes up and down, so it reflects it on the outside. I could do it on the computer to show you, but it's easier for me to draw it out. So like this one right here is going to reflect across the X. But the way I remember it is up and down. It's going to reflect up and down because it's on the outside. Okay. So the way that I do it, and the reason I want to draw it, is that I look at this and I say, okay, this is 3 above the x-axis, so I go 3 below the x-axis. This one is 6 above, so I go 6 below. This one is 2 above, so I go 2 below. And that will make my graph. So that is the easiest way to do that. So do 3 above, 3 below, 6 above, and just stay on that same line, 6 below, 2 above, 2 below. All right, on the other one, it's on the inside. So technically it reflects across the y-axis. But the way I think about it is it's on the inside, so it's going to do stuff left to right. So the way it always works for these transformations. So on this one, instead of going up and down, we go left and right. This one's 2 to the right, so I go 2 to the left. I guess the only other point I have right here is this one. This one is 6 to the right, so I go 6 to the left. So if the negative is on the inside, it flips it left and right. If the negative's on the outside, it flips it up and down. So like if I was doing this on the computer, I'd just go, okay, 3 above, 3 below. Well, I put it 4 below, but y'all see what I'm saying? I just go look. Come on. Ignore that dot. 3 above, 3 below. 6 above, 6 below. Like I just do it like that. All right, what's next? 5. On this one, you are going to be asked to figure out where this one is constant. Okay, so you can get increasing, decreasing, or constant, so pay attention to what it asks for. I guess we don't even need all that. Okay, so I might go over each of them. The actual answer here is constant, so you are only looking at this right here. So my answer to this one is -3, -5 to -3. So one thing when you're talking about this, you always want to use your x values and use parentheses. Okay. So that's the constant. It will change on you though. So if it asks something for like increasing, that would be this one is increasing and this one is increasing. So if I look at my x values, that would be from -3 to -1. And I got to do this one over here, 3 to 6. I don't care how much it's increasing or decreasing. I want to know where it is. So I use my x values. Okay, and if it said decreasing, now again on the test, you're only going to have to do one of these, but I figured since we're reviewing, we'll go over all of them. The decreasing would be this one and this one. So that's from -1 to 3. And 6 to 7. Okay, so always use your x values and you always use parentheses on these because you're never bracket, it's never equal to a point. If you're at a point, you're stopped. You're not increasing or decreasing or constant even, you're just stopped. So you will only have to answer one of those, so pay attention to which one it says. Oh, no, I didn't save the last one. I'll have to go back and do that at the end. I forgot to save it. All right. Do I have the wrong number on this one too? This one says talking about the vertex. Okay, so I think I got the wrong number on the test worksheet on this one too. Okay, this one, all the values at which h has a local maximum. So the local maximums are where it kind of peaks. Okay, where it peaks, where it says at, that is going to be my x values. Okay, X always tells me the location, Y tells me what it is. So the way I always remember it, at X is Y. This is a location. This tells me what it actually is. All right, so it is at -2 and +2. And then my actual one is the Y values. What are they? Is the Y values? It would be 0 and 3. Okay, so what local means, what the word local means is that you are ignoring the infinity and negative infinity that goes up forever or down forever. You're just looking at like the peaks and the values. It will switch between maximum and minimum. So like if it asks for minimum and you wanted to use these 2 points. Okay. And it always has exactly what the point is. -2 and 0, 2 and 3. So it's at -2 and 2 and it is 0 and 3. Can't believe I didn't save that one. Maybe that's just bad wording. I wonder if, sorry, because number 7's not the right one either. I wonder if I need to word this better. And this is, maybe they gave me, when I was looking at my example, they gave me a, so if we were to write, my goodness, I'm going to change a bunch of words on here. I think what I want here is what I wrote right there. -2, 0, and 2, 3 were my points, right? So you, so the max is at -2 and 2. Maximum is 0 and 3. I think that's what I was wanting, is like that kind of thing right there. That this tells you where it is. This tells you what it is. That's kind of what I want there. I think I used the word vertex because I didn't know, because it's going to switch between maximum and minimum, and technically like that is a vertice. There are multiple vertices on the problem we had. I probably just got one on the example that I did when I was making this. But yeah, what I'm looking for here on this one is the X tells you where it is, the Y tells you what it is. It's kind of the problem when you're coming up with something like this and then you got different variations. All right, let me write this one out. 2x cubed and x squared. And then we are supposed to find minus, plus, and times -1. Okay, so to do these, you got to do each one. Alex does give you points, like if you get one right and one wrong. But you are doing R of x minus S of x. So this would be 2x cubed minus x squared. You can't simplify that at all, so that's it. On this one, you are doing r of x plus s of x. So you do 2x cubed plus x squared. Can't simplify that at all, so that's it. On this one, you could do it two different ways. I don't feel like we did this one in class, so like the two different ways. But you can, since we've been doing it like this, we can say r of -1 times s of -1. I actually think this way is easier. So to find r of -1, you plug in a -1. So that'd be -1 cubed would be -1. That'd be -2. To find s of -1, you square it. So that'd be times 1. So my answer here would be -2. So you plug a -1 into each of them, and then you multiply your answer. The other way to do it is you can multiply first. So like 2x cubed times x squared would be 2x to the 5th, and then plug in the -1. So that'd be 2 to the -1 would be -2. Oh, wait. -1 to the 5th would be -1. I think it's easier to plug it in first. Plug it in first and then multiply them. But either way, whichever way you prefer. Oops. On this one, I do say to show your work for one of the parts, x squared plus 3 squared to x plus 2. I don't care if you show your work for both of the parts. What was it? Oh, it was p first. X squared plus 3, x squared plus 2. I wouldn't write this down yet. Let's make sure I got it right. X squared plus 3, x plus 2, and then we're plugging in 2. Okay. So this is the composition of functions. What you are actually doing is I work it backwards. You plug a 2 into Q, and whatever you get out, plug it into P. So to find Q of 2, I plug it into Q, or I plug 2 into Q. That'd be 2 plus 2. The square root of 4 would be 2. So now I know Q of 2 is actually, the answer is 2, so I take that and plug it into P. So 2 squared plus 3 would be 7, and 7 is my only answer here. I'm actually going to delete that circle. So on the next one, I'm working backwards. I plug a 2 into P, and then whatever I get out, I plug into Q. So when I plug a 2 into P, I get 2 squared plus 3 equals 7. Now I'm going to take that and plug it into Q. So the square root of 7 plus 2, if they give you a square root, it's going to come out easy, so that helps you know you got it right. Yes.
Would there be two answers for the first one, or just one answer just because it's a radical?
Because what was the last sentence you said there? Because what?
It's a radical. So would it be plus minus 2 and then you plug both in for P of 2? Or is it just 2?
It's just 2.
Okay.
Because I'm only asked to plug in positive 2.
Okay.
You only do the plus or minus if you take the square root inside an equation, like if you're solving it. But I'm only asked to plug in positive 2, not negative 2. So, yeah, I get where you're going with that. So you are supposed to show one of these on the test work page. I don't even know if it lets me copy and paste, but let's see. So I don't have. You're welcome to write both of them on here if you want to. It's not going to let me copy and paste. I'm not going to do that. I'm just going to put. Show on test work page. All right, number 10 is our other one. Domain and range of a linear function. So number 9, 3 left. Kiko is a software saleswoman. Let P be Kiko's total pay in dollars. Let N be the number of copies of History is Fun is sold. Kiko has 140 copies available to sell. Suppose that P equals 10 times N plus 3,600 gives P as a function of N and the available copies. Identify the correct description of the values of the domain and range. So the domain and range in real life. So domain is always the numbers that you are plugging in as the input. So if, I'm guessing P is like profit, right? Total pay, yeah. So N is the number of copies sold. So that is, if I sell more copies, I get more commission, right? So my domain is going to be my input. My range is going to be my output. And the set of values that you could use for the number sold, she has Kiko has 140 copies available. So it would be somewhere between 0 and 140. Like Kiko could sell 0 or they could sell 140 because they have 140 copies available. To find this one, let me select the correct answer, then I can write it out and tell you. Oh, I got it. Okay. To find the range is your output, so it is based on your input. Okay. So you have two different options here. So this is my input, and this is my output. Your two different options on this are your smallest number that you could sell is 0. So 10 times 0 plus 3,600 would be 3,600. So no matter what, Kiko is going to get paid 3,600. That's her base salary, right? If that's the minimum amount, and then the maximum amount Kiko could sell is 140, and that would be 5,000. So you do have to use your input to figure out your minimum and maximum output. So Kiko is going to get a base salary of 3,600, but if Kiko sells all of the 140 copies, could get up to 5,000. So it did it to me again on the... Actually, we probably changed that to number 11. All right, number 10. Finding the domain range of a graph. Ivan is exploring the formula for the circumference of a circle. So he does it and graphs it based on the radius, compares the radius and the circumference. So this is just the domain and the range of a graph. Like, you just got to look at this. So again, your domain is your x values, so it's left and right. So it would be, the radius could be 0 all the way to infinity. And the range, again, could be 0 all the way to infinity. Right, your answer is inequalities. Oh no, not interval notation. Should have read the question first. So it would be x has to be greater than or equal to 0. And this one would have to be y is greater than or equal to 0. A lot of times when you do real life scenarios, this is the way those work out because you just want a number 0 or bigger. Again, when y'all take this test, I know this is only our second test, but when y'all take this test, review it. If you accidentally do interval notation, but you get it right, like I'd give you full credit. So review your test, and I will give you partial credit on stuff. All right, the last problem here, I'm guessing on our worksheet here, this should be number 11. I'm sorry that I messed those all up, the numbers, but this makes more sense to go with 11, so let's do this problem, and then we'll move to 11. For each parabola, choose whether it opens upwards or downwards. This goes along with our test sheet, but if a is positive, it's going to go up, or if the number in front of x squared is positive, it goes up. If a is negative, it goes down. So this one is going to open downwards, upwards, downwards, downwards. So if it's positive or negative, it tells you whether it opens up or down. The narrowest graph, okay, if you got to think about this for a second, that is fine. But the narrowest graph, that does not matter if it's positive or negative, it is how fast it goes up. Okay, so what that is going to do is, let me just draw a couple pictures here, I guess. If I have this as x squared, if I multiply that by like a 5, it's going to go up super fast. It's going up 5 times as fast as x squared, okay? If I multiply that by like 1/5, it's going to go up 1/5 as fast. And it's going to look like this. So if it is a number between 0 and 1, it is going to get wider. If it is a number greater than 1, it's going to get narrower, okay? So on this one, it does not ask whether it's positive or negative. So the positive or negative does not matter. You are just looking for the biggest number. And on this one, you are looking for the smallest number. 1/4 is smaller than 1/3. It does not matter. I say biggest and smallest, but the absolute value of the biggest or smallest. The positive and negative do not matter. That just tells you whether it opens up or down. So if I'm looking for the narrowest, I'm not asking. I don't care if it opens up or down. I just want to know which one goes up or down the fastest. All right, to the test worksheet. Sorry that I messed up all these numbers. I don't know. Y'all are the first time I've done this, so, just bear with me. So we need to change 3 and 11, and that other problem, just deal with the maximum and minimums. Shown above. Okay. So A is positive, opens up. B is negative, opens down. If it is a large integer, it is going to be narrow. And if it's some fraction between 0 and 1, it is going to be wider. So it goes right along with the problem. And I don't care if you want to just draw a picture, like that tells me that you understand it. Opens up, opens down, narrower, wider. All right, so that is everything on the test.